So, Bismillah ar-Rahman ar-Rahim, continuing with the 0620 March 2023, paper 2, variant 2, right? If I'm not mistaken, it's 22. So, yes, paper 2, extended multiple choice, variant 2. We've done half of it. So, let's continue with question 21. Copper to sulfate is prepared by adding excess copper to carbonate to sulfuric acid. Why is an excess of copper to carbonate added? Yes.
B.
Are you asking me or are you telling me?
Telling you.
So ensure all the sulfuric acid is reacted, and that is correct. All right. So part of the periodic table is shown. Which element has 2 electrons in its outer shell and 3 electron shells?
C.
Yes. Right, and so what you want to do is you number the groups. So group 2 has 2 electron shells, so it's either B or C. Sorry, not number of shells, number of electrons, outermost electrons, so that's 2 over here. And then the periods are the number of outermost shells. Oh, sorry. So you need to number them carefully. And this, if you number it from here, this is 1, 2, and then 3. So that's C.
Yeah. Okay.
All right, so don't forget that hydrogen is hydrogen helium in the first period with one outermost shell or one electron shell. Okay. Elements in group 1 and group 2 show the same trends in the reactions with water and in their density. Which row shows how the properties of barium compare with calcium?
In which group calcium is?
Right, so what we can do is we can obviously take a look at the periodic table. Let's go down. And so barium is down here. It's in group 2. Calcium is also in group 2. Right? So they're both group 2 elements. Now, what is the reactivity going down the group? Does the reactivity increase or decrease?
Increases.
It increases, right?
Yeah.
And what was the other, the density? Yeah. So would the density of barium be higher or lower than calcium?
Higher.
So that's A.
Okay.
Okay.
Yeah.
Which pair of compounds shows a transition element in two different oxidation states?
B.
Yeah. Same.
All right, so this is copper 1, this is copper 2.
Yeah.
Right,
The first one.
both of these are chromium 3. Right, both of these are zinc 2. Right, and both of these are nickel 2. You had a question, Haram? Haram?
No.
Okay. All right. Which description of brass is correct?
C.
Yes. So it's an alloy is a mixture, not a compound. Right? A compound suggests that there has been a chemical reaction, which is not true. But alloys.
Yeah.
Right? And then you need to figure out, okay, which two actually go in there. So it's copper and zinc. All right. What is the symbol of the metal used in the manufacture of aircraft because it has low density?
I'm gonna take a guess and say A.
Zinc.
Yes, Haram?
Option D.
B. Are you saying copper?
I'm saying D.
D, zinc.
Zinc.
No. So it is most certainly aluminum.
Doesn't it has
Huh?
doesn't it has high density?
Compared to the others, no.
Okay.
Right. Again, if you take a look at copper, iron, and zinc as compared to aluminum in the periodic table, right, you've got aluminum over here in group 3 and period 3. Right, it has a mass of 27, whereas you got zinc with 65, copper with 64, and iron with 56. Right, and so you would assume that they are more dense because the atomic size isn't going to be remarkably different as compared to aluminum. Right, so these are much heavier as compared to aluminum. Right, plus the book goes into detail of the properties of aluminum that make it good for aircraft manufacture and all of that. So, all right, which substances react to form hydrogen gas?
Option A.
So calcium and water, so that's okay. Acid and metal, so metal and water. Then this, and then magnesium and steam. Right, and then zinc and dilute hydrochloric acid. So yes. All right, so for all of these, you can revisit the reactivity series and all of that to check how these and the chapter on metals to see how these reactions take place. But it would be
It's
option A.
the option given are 1, 3, and 4.
Yes. Oh, sorry, my bad. I picked the wrong one. So yeah, silver is super unreactive. Okay. Question 28. Coke, which does not mean your cola, right?
Yeah.
Carbon and limestone are two raw materials used in the extraction of iron from hematite. Hematite is the name of the ore. What type of reaction occurs when each substance is heated during the process? Right? What's happening to the coke and what's happening to the limestone?
How many electrons does carbon have in its outer shell?
4.
Is it B?
B.
Yes. So limestone is calcium carbonate, right? And that's heated to decompose, right? Giving you calcium oxide, oxygen. And the coke initially reacts with oxygen to form CO2, right? And then the CO2 reacts with more carbon to form carbon monoxide. So it's oxidized and then it's reduced,
Yeah.
right? And all the other steps. So that's the okay. Some combustion reactions produce pollutant gases. Which reactions produce a pollutant gas that is not present in the air?
B.
B.
Yeah.
So that's 1 and 4.
Yep.
H2O is not present in.
Moisture, right? So air does have moisture.
No.
It's not a gas per se. I mean, right? Present as moisture, it is and it's gaseous, right? So carbon monoxide is not something that you normally find in air. Carbon dioxide is something that you find in air, right? And then obviously water moisture is something that you do find in air, right? Carbon monoxide is not something that you would normally find in air, and right, uh, oxides of nitrogen are also not something that you would normally. So nitrogen on its own is present in here. It makes up the majority of air, right? Not oxides of nitrogen. So
Answer.
hmm,
It would be D.
it's going to be B.
B.
Yes.
But like carbon dioxide is not
It's not.
present in clean air.
We're talking about carbon monoxide and oxides of nitrogen. So it's
Okay.
1 and 4. So it's B. Okay.
Yeah.
So 1 mole of alkane Y produces 72 decimeter cube of carbon dioxide when burned in excess oxygen, measured at room temperature and pressure. What is, alright, so if you're talking about complete combustion, what are you going to do? Alright, we're talking about carbon dioxide, that's CO2, right? What is the volume of 1 mole? Okay, so 1 mole is 24 dm cube, right? And so 72 dm cube is 3 moles, right? Which means you need 3 carbons, which is propane.
Yeah.
Okay, the structure of organic compound X is shown. What is X?
C. Math is 1 or 2.
Hmm? Meth
Math
is
is
1.
1 or
Meth is 1.
2.
So you're going with C. What about you, Sobia?
Same.
I'm playing with B.
Okay, so the naming is confusing, right? So when you're drawing the structure, you draw the acid part first, and the alcohol part second. But when you're naming it, you're going to name the alcohol first and the acid second. So the alcohol is one carbon, that's methyl, and the acid is two carbons, so that's ethanol. See? Okay?
Yeah.
What is the structural formula of the compound formed in the addition reaction of propene with bromine?
What's the general formula for alkene?
CnH2n.
Okay.
In
A.
case of,
Propene is 5.
so this is what propene would look like. Or the other way around. Right? Point being that you're going to get one bromine on the first carbon and one bromine on the second carbon. Right? If you flip this around, so that's what you're getting. You're getting one bromine on carbon number 1 from the other side, and then one bromine. Right? You're not going to get both bromines. Obviously, C and D are completely out. Right? And 1, 2, and 3, and yeah, so it's not going to be scattered to the ends because that's not how double bonds work. So you're going to get A. Ethanol is produced industrially by fermentation and also by a catalyzed addition reaction involving steam. Which row describes one advantage of each process? Hmm?
Is it A?
Aram? Any guesses, Aram?
It would be B.
B,
B.
C, D. Which one?
B.
This one, right? The reactant used is renewable and it requires little energy. So you're both agreeing on the reactant used being renewable,
Yeah.
right? So it would be A,
Yes.
right? The good thing about the catalyzed reaction is that it's a continuous process, right? It does require energy to break the bond. So yeah. All right. Carboxylic acids react with alcohols when warmed with an acid catalyst. That's the formation of esters. What type of substance is formed? I just gave you the answer.
B.
B.
Yeah.
Oh, look.
Same.
Nylon is formed by condensation polymerization. Which structure represents nylon?
Can you help us with this one? Okay.
Okay, so right, what happens in nylon is that you are using a dioic acid and a diamine. right? Which basically means you're using a molecule that has the carboxylic acid group on both ends. And you are using a molecule that has the right NH2 group on both ends. So when you put these two together, right, what you can see over here, the problem with A is it's a single molecule that has the carboxylic acid and the amine, right? And so this is basically a peptide. So this is a protein, right? It's not nylon.
And why is like one block shaded and the other one is not?
Huh?
Why is like one block shaded and the other one is not?
Oh, that's showing like the central part of the molecule is different. So there are two different molecules
Okay.
in principle, right? So you could like shade any one of these.
Okay.
The problem with this bonding is you don't see two amide groups linking together. You don't see two carboxylic acid groups linking together. So that's wrong, right? What you would expect when these two guys come together, right, is a CO NH bond being formed and water being given off. Then that's called a condensation reaction, right? And that's why this is called condensation polymerization as opposed to addition.
So it's C.
Yes, right. The problem with uh, what's the problem with this
Because
one?
C and O are
Yeah,
together.
so you've got C and right, so the acid has only lost it's got both its oxygens left, it's only lost a hydrogen, the amide is, and so basically what they're suggesting is what's lost is a hydrogen molecule, which is not what happens. Okay, so your answer is going to be C. So you need to study, right? And so now the shading makes sense, right? The shaded molecule is the dioic acid, right? And the clear molecule, whatever is the structure, right? We're not concerned with that. There's got amide groups on both ends, and so that's the diamide. Okay, and so you need to know how the bonding works to figure this out. Right? This is a correct molecule. It's just not nylon, right? This is a peptide protein.
Yeah. Okay.
All right. Question 36. Which structure represents the repeat unit of the addition polymer formed from but1-ene? Right? So how are we going to solve this? Right? They're telling you the position of the double bond. And so what you want to do somewhere, so let's do it over here. Butene has 4 carbons. The double bond is on the first. Right? You've got hydrogens over here. Oh, too many bonds for carbon over here. Right? Now, what you're going to do, again, you have too many bonds. So be careful of the number of bonds you're putting in. So what you want to do to make this easier is you just want to focus on the part that has the double bond. And so you're going to write it out like this. This guy has 2 hydrogens. This guy has 1 hydrogen here.
Is it gonna be A?
Just a minute. And then
Okay.
it has this entire part. You're going to clump it together, right? And so it has 2 carbons and 5 hydrogens. And so that's how you're going to represent it. And then you're going to think about, okay, addition polymerization, right? So the double bond is going to break open and it's going to form single bonds on both sides. That's what you're getting. That's A.
Okay.
All right.
Yeah.
All right. 2 grams of powdered calcium carbonate is added to 50 centimeter cube of hydrochloric acid. Which apparatus is used to measure these quantities of calcium carbonate or hydrochloric acid?
It would
Hmm?
Mm.
Yes?
it would be
A. Yes, Sobia?
Uh, A.
Yes. Calcium carbonates are solids, so you're going to use a balance. Right, and so the other option you have, right, it's either a burette or thermometer. Thermometers are not used to measure volume, so right, burettes are, and so you get A. Chromatography or chromatography. The diagram shows a chromatogram obtained from the colors of 3 different sweets X, Y, and Z. How many different red dyes are present in this? Yes.
Is it at B?
Yes. So these two guys are the same, and these two guys are the same, right? And so they count up to how many different red dyes, not how many red dyes in total. And so there's 2 different red dyes that have been used. A mixture contains sand and an aqueous solution of sodium chloride. Which processes are used to obtain a sample of solid sand and a sample of solid sodium chloride from the mixture? Yes.
Is it gonna be C?
What?
C?
C.
C. Yes. So the filtration is going to trap the sand, and the crystallization is obviously going to turn the sodium chloride solid. And finally, right, a student tests an unknown compound M, right? The compound produces a lilac flame using a flame test and produces a gas which turns lime water cloudy when dilute hydrochloric acid is added. What is M?
B or B or A.
Huh?
B or A.
B or A?
Yeah.
D.
Right? So
So
whenever you have lime water going cloudy or milky or white, you've got carbon dioxide. And that means you need a carbon. So it's either B or
it
D.
would be B.
Right? Lilac flame is for potassium. Right?
Oh,
So you need to, like, in paper 4 they give you the tests, but in paper 1 and 2, like I said, you need to know the tests, right? And so what you have is K2CO3, potassium carbonate. All right.
Yeah.
Right, so we're done with another paper 2, and next time, I guess, right, so it's up to you. What would you want to do? Would you want to do a paper 4 or a paper 6?
Which paper have we done least between these two?
Well, we've done one round from the specimen, and now we're doing another round from the March 2023 series. Right, so we've done 2 paper 2s, 1 paper 4, and 1 paper 6.
I think we can go for paper 4.
So the theory
Pardon?
type.
and go with ATP.
So
Yeah.
basically, it's up to me. What we could do is we could take a cursory look at both of them, not doing
Yes.
right. So not necessarily doing each and every question, just looking at the different questions and discussing how to approach them rather than solving them in detail.
Yeah. Okay.
That's what we
I'm
could do.
fine with either of them, so yeah.
Yeah. So that's what we could do.
Okay.
Yes.
All right.
Okay.
All right then. See you next time, inshallah.
Okay. I love you.
Allah Hafiz.
Allah.